Okay, so this problem says we have to conjugate a letter ABCD. ABCD. So side AB and BC have length 10. So here AB 10, BC 10. Okay. Side CD and DA 17, 17. Okay. And the measure of the angle ADC, so this is 60. Okay, so if we connect AC, so we know this 17, 17, this 60, so we know these two angle also should be same, 60, 60. So this ADC, triangle ADC is equal trilateral triangle. So this means AC also equals 17, right? Oh, this problem really easy. What is the length of a diagonal AC? AC is just 17. Okay, so now let's consider the problem. So ABCD is a rectangle. So EFGH is a program. Okay, so this is 4, 6. Okay, so 5, 3, 4, 6, 5, 3. Okay. So what do we want to find? What is the length D of a segment that is perpendicular to HE and FG? So this is perpendicular. Okay. Okay. What is D? So for this problem, we can say like we can find the area of AFGH. So we can denote this as AFGH. This area so equal. First we say equal H multiply D, right? So this H 3, 4, so H is 5. So this equals 5D. So on the other hand, this area HH. Sorry, on the other hand, we also have this EHGH. So area equal this rectangle minus so the 4 triangles, right? So this equal 10 multiply 8. So minus this 4 triangle, but this 4 triangles, this the same, this the same. So we just say this, so minus this one is 5 times 6 and 3 times 4. So we let this so equal 5D equals this, so we can find this D. So there's a question. So we have something. A finger is constructed from unit cubes. So let's say we can put this cube. Okay, one unit cube. Okay, and like this, like another, and let's say we can have this. We can put these 3 cubes together to make this. Okay, so each cube shares at least one face. Yeah. Okay, so the question: what is the minimum number of cubes that to build a finger with the front and side views like that? So front. Okay, so front is like this. So we should have like this, right? Or we have like here. We should have front. So we should have those things, right? Okay, so at least we should have 3. Okay, so maybe we can also have like we can have this, right? Yeah. Okay. Oh. So front view is this, and the side view this. Front view, side view. So side view is this. So what is side view? Front view. What is side view? Side view from that side. Or from which side? Okay. Okay. So maybe like so if we say this view, front view, and this view, side view. So side view should be like that. Okay. Okay. Side view. Okay. So we can say, I think side views should be like this. So it just is like okay. So we should look like that, like side view. This view is okay. Front view, side view. Yeah. Okay. So what is minimum? Minimum. So minimum, I think minimum is we just put this 3 cube, like this cube. So here is 3 cube, right? 3 cube, and we just plus 1 more. Okay. Okay, like this one. Okay. So the minimum number can be that's 4, right? Yeah. Okay. So for this problem, it says the following figures are composed of squares and circles. What figure has a shared region with the largest area? So we just find the area for the shared region area. So for this one, A is, so this is 1, right? So this equal 2 square minus pi, right? And this one, okay, so this is 2, so this one equal, let's say 0.5, right? Okay, so this one is 2 square minus 4 times 4 of this small circle 4 pi, so pi is half. Pi 4. I'm sorry, 4 pi r square pi. Okay, so we can find this a and b the same, and this this equal 2, so this equal 2. Okay, so like this equal 2. Okay, so 2, and so this equal to this equal radical 2. So here, so this equal pi 2 square. This is 2, right? So minus this square. This area for the square. The square is radical 2 times radical 2. Okay, so we just check out which one is big. Okay. Okay, so for this problem, it says the area of the square wxyz is 25. So wxyz is 25. So this means this is a 5. Okay. So the 4 small square have side of 1. Okay. So either parallel to or coincident with the side of the large square. Okay. So here we have this 5 and this 1. So it's like, so we have this 4, so square line. Okay. So 1, those 4. The 4 smaller squares have sides 1 is parallel to or with the side of the large. Okay. Okay. So this is in triangle ABC. So AB equal AC. AB equal AC. And when triangle ABC is folded over the BC, the point A coincide with O here. So the O is the center of the square WXYZ. Okay, so then what we want to find? What is the area of triangle ABC? Okay, so A, there's a point, and there's a point O will be coincides. So this means like, okay, so we connected the 2 points, and okay. Okay, so let's say, so we can find the distance between O to this supposed point. We put this as M. And okay, So what is BC? What is OM? Or what is AO? What is MO? So we find MO is just equal this is 5, this is 2.5, this equal, so this equal 2.5 plus 2, right? So MO equal 4.5. Okay, and what is BC? So BC equal 5 minus 2, right? Minus 1 here, minus 1 here, minus 1 here. Okay. Oh, so equals 3. BC equals 3. Okay, so the area for triangle ABC equal, so we say triangle ABC, the area for ABC just equal half BC multiply AM. So BC equals 3, AM equal MO equal 4.5. Okay, so we can find this area. Okay. Okay, so this problem says from those points from A, Y, Z, X, from these 6 points, how many triangle? So how many non-congruent triangle can be drawn? So such a problem, so let's say, let's count, okay, so if we choose, maybe I just use this, okay. If we use these 2 points, then we can have this one, and this one, and this one. We just pick other 3, right? So we cannot pick this. So here, if we choose this, so we have 3 triangles. Okay, and if we pick these 2, so we will also get this 3. Like, okay, like connect this point, connect this point, connect this point. We get this also 3. But we cannot count for this 3 because these 3 triangle and those 3 triangle are same. Like this one and this one, same, right? So we can only count for 3. Okay. And so we can consider like this: if this side is 1, one side are how many triangles? Like we can have 1, so we can choose this triangle, so this one, and this one, and this one. We have this 3 triangle, right? Okay, so and then how about if we pick RT? So let's see. So this side is 2. So this side is 2. So we have these 3 points. So we already pick these 2 points, and we can pick these 3 points. 3 points, pick any of them. So we can get this one, or this one and this one. So it seems we have 3 triangle, but this one and this one the same. So here we can only plus 2. So the triangle, how many triangle? We just have 5, right? So we have, if this is 1, then we have 3. If this is 2, we have 2. So no other more. Okay, so 5. Oh, not 5. Oh, let's say, okay. So maybe, so our answer should be 5, but no 5. So here, let's say this is 1, this is 2, this is 1. So this triangle and this 1, like 1, we have 1, 2, this 1, the 2, and this is 1, 2. These 2 triangles the same. So answer is 4. Okay, so maybe let's repeat. Okay, such a problem could be very easy to make a mistake. So at the first we say we the focus on side is 1. Okay, so here we have only 3 points can pick. So pick this one, this one, then so we here we can produce 3 triangle, right? Like these 2 points. So this one, or this one, or this one, right? We can produce this 3 triangle. Okay, so then if we pick one side, is pick these 2 points. So this side is 2. Okay, and so for other side we have 3 choices. Could pick, we can pick this one, pick this one, pick this one. But pick this one and this one the same. There's 2 triangles, same triangle, same. So here we can only count 1, and then pick this one. So it seems we from here we have 2 triangles. But this one, okay, this triangle, okay, so this is 60 line. We have this triangle 2, 1, and this is 60. So such triangle and this one, we see same, right? 1, here 1, pick this one, 2. This is 60, right? So these 2 triangle the same. So we should minus 1, right? 3 plus 2, we should minus 1. So 4. So for this problem, and it says each half of the finger is composed of 3 red triangles, 5 blue triangles, and 8 white triangles. So this is when the upper half, is folded down over the center line, we find 2 pair of red triangle coincide, 3 pair of blue coincide, and 2 there are 2 red white pair. Okay, red white pair. So we want to find how many white pair we want to find this. So for such a problem, we just try to draw the case. We just consider some case. So we just say, oh, okay. So let's say we have two pair of lead triangle, two pair of Okay, so two pair. So means we have suppose this one is the lead one, so this one is the lead one pair, right? So and we put it here lead one, so lead one. So we have two pair of lead triangles and three pair of blue one. So we say if blue here, then blue here, yeah. So blue here, blue here. Okay, so blue here, blue here, blue here, blue here. So we have how many? Three pairs of blue. So there are two red and white pair. So this is the two pair. They are two red. Okay, so we say here this one is red, and then they are two red white, and red, and okay. So each pair we have three. So here we have already three R. So by now we say so we put this is R. We have three red in this half. So then this is W. Okay. Okay. So let's check the all others can be like can be. So let's check here half of this. How many B? So here 4B. So we have 1B in the top, right? We already have 4B. Let's say we have 3R. Yeah, 3R. 3R already there. 3R and 1W. So let's see how many W. 7W. 1. So we have other blue ones. Yeah, let's say totally we have 5 blues. So by now we have 4 blues. So need 1 blue. Yeah, 1 blue, and we have 1 blue and W. So how many W? We have 8. 8. So here we have 8. So 1 blue. So okay, so we should have 7, 8, like 7 blue or 7 white. So we put 7 white. Let's say so 1 blue to where? So blue. So here. So and so then here we need to check. So we just put white. Let's say I put white 7 1 2 7 white. Then I put blue here. Okay, and then so we check a button. Check a button. So button we have here we have already have 4B. 4B. So no. Or we have 1B. Yeah, 1 blue. Okay, and we have 3R already. So no R. Yeah. Okay. So 0R. Okay. And we we have only ordered one W. So here we should have 7W. Okay. So we just put this 7W here. So we can put it as 7W. Okay. So we only things we cannot put a W here, because if we have a W, then we have a WB, this pair, right? So we say so where we should put it where we should put a B. B let, okay, so maybe we can put a B here. One B, we should put a B here. Yeah, we cannot put a B here, because if we put a B here, we have, yeah, we have 4 pair of B. Yeah, so we cannot put a B here. So this one should be W. Okay, so then all should be W. Like W. So we can check how many pair. So 1, 2, 3, 4, 5, 6. Okay, so I think we have 6 pair. Okay, so we can stop here.